Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking in Geometry Part B. This is Lesson 3. We're looking at dilations. Again, information covered in the lesson content. So please follow along in the lesson while you're watching this recording. So let's take a look at what a dilation is. So what is a dilation? So a dilation with a center 0 and a scale factor of n, where n will be greater than 0, is a transformation. Now, we've talked about transformation in other lessons, reflections, rotations, and translations. This is a dilation. So now it has these properties. Remember, all of those previous ones were congruent transformations. In other words, the pre-image and the image were congruent. So let's take a look at what happens with a dilation. So here is what a dilation looks like. So you see that the size will change as we go through the process. So the image of C, which will be the center, is itself. In other words, C prime equals C. That's not a big deal. That just kind of lets you know that C won't move. The center of dilation will stay where it is. For any other point, and we're looking at point R, R prime is on CR. So see, R prime is on that line CR, or that ray CR. And CR prime, in other words, the distance from C to R prime, is based on a scale factor, which is this n right here. And n will equal the distance from C to R prime divided by CR. In other words, right here, you're going to find the distance or the length of the image and divide it by the length of the pre-image. That's how you're going to find the scale factor. The image of the dilation is similar to the pre-image. Now, we just talked about similarity in a couple lessons. These two are similar, but they are not congruent. All angles are preserved, so that's a big point. So angle P prime right here, that's going to be the same as angle P. So angles are preserved. Just the lengths of the sides will change. And a dilation with a scale factor greater than 1 will be an enlargement, which is what this is. This is an enlargement. So the scale factor here will have to be larger than 1. And if you have a scale factor that is less than 1, it will be a reduction. So let's take a look at an example of an enlargement and a reduction. So here is an enlargement. So you see that we have this parallelogram. This is the original parallelogram, PQRS, and it is transformed into P prime, Q prime, R prime, S prime. You see it gets bigger. So that is an enlargement. So the center here is P, which, finding the center isn't the most important thing we're going to talk about, but you need to be able to identify the center. And the scale factor, to find the scale factor, we're just going to take this segment right here, RS, because we know its length is 3, and we're going to divide by, or this is R prime, S prime, excuse me, and we're going to divide by the length RS, because we know those two values. And the scale factor here will be 3 divided by 1.5, which is 2. You see 2 is bigger than 1, so yes, this is an enlargement. So let's take a look at a reduction. So here is a reduction. We've got 2 trapezoids here. So the larger trapezoid, A, B, C, D, is the pre-image, it's the original object. And the smaller one, A prime, B prime, C prime, D prime, is the image. You see it is a reduction. To find the scale factor here, we're going to take B, C prime, so B prime, C prime, which is 1.2, and we're going to divide by BC, which is the image or the pre-image length, 3.6. We've got center of D. Then we have a scale factor, B prime, C prime over BC. That's 1.2 over 3, or over 3.6. This is 1/3. Do not confuse that with being 3. Just because 12 goes into 36 3 times does not mean that this equals 3. The smaller number is on top, so this will remain a fraction. So this is a fraction of 1/3. So let's take a look at how to actually do some problem solving here. So here's our first problem. We want to find the scale factor and then determine if this is an enlargement or a reduction. So we can already tell that this is going to be a reduction because the bigger object is the pre-image. So let's find the scale factor. Scale factor is always image over pre-image. So in this case, we're going to find A prime B prime over AB, which is 10 over 25. Both of those divide by 5, so this is 2/5. Now, because 2/5 is less than 1, this is a reduction. So that's really kind of all there is to some of these problems. Let's take a look at the coordinate plane, because this is kind of the focus of the lesson, is things in the coordinate plane. There's two types of dilation. This is the first type where we have a center of 0, 0. This is the easier dilation to perform in the coordinate plane. So let's take a look at our given picture here. We've got triangle ABC, and we want to dilate that triangle about the origin with a scale factor of n equals 2/3. Now, important note here, this is not written, so write this down. It is written in the lesson content. Unless you're told that the center is some other point, the center will always be the origin, 0, 0. This is you're told here that it's the origin. So always assume that if it just says to dilate the object without telling you any point of center, then the center will automatically be 0, 0. So we're going to use a scale factor of 2/3 here. So let's take a look at what we got to do. So first thing we're going to do is we're going to find our coordinates. A is at 6, 3. B is at 3, -3. And C is at -3, 0. So all we've got to do now, since the scale factor is 2/3 and the center is 0, 0, we're just going to multiply these points by 2/3. So here is A prime. So we're going to take 6, 3, multiply it by 2/3. Now how does this happen? Well, this is how I do this. 3 goes into 6 2 times. 2 times 2 is 4. 3 goes into 3 one time. 1 times 2 is 2. So that's how I get the points when I do this. So that's our first point. So let's plot that. So there is 4, 2 right there. 1, 2, 3, 4, 1, 2. And that is A prime. Let's take a look at B. So B prime, we take 3, -3 again, multiply it by 2/3. 3 goes into 3 one time. 1 times 2 is 2. 3 goes into -3, -1 times. -1 times 2 is -2. So that's our second point. -1. And I put those backwards. So there's the point. -2, -2. And that is B prime. So we got our first segment right there. So let's find C. Same deal here. We're going to take -3, 0. Multiply it by 2/3. 3 goes into -3 one times. 1 times, or -1. Excuse me, -1 times 2 is -2. Anything times 0 is 0, so that's just going to stay 0. So our last point will be -2, 0. So that's C prime. And there are our final points, and that's our dilation. And you see this is a reduction. So the final thing we're going to look at is a dilation that is not around the origin. So these are the more difficult ones. Pay attention to this series of notes and information. It is in the lesson content, but me talking through it will probably help you a little more than that table I did in the lesson. So here is our given picture. And you notice that we have a point right here. That's going to be the center of dilation. So we're going to dilate triangle PQR about point C, which is 1, 1. So now how we're going to do this? Well, you need to set up a table. Now in this table, we're going to have 4 columns. I have 5 in the lesson. 4 is good. And we're going to find the point first. We're going to find the distance from the center to the point. Then we're going to multiply that distance by our dilation, which in this case is 3. I didn't say that. So we're going to dilate about 3. So let me put this. So I'll put scale factor 3 right here. At least I think I am. Here we go. Scale factor. 3. So there's our scale factor. And so let's start with the first point. First point is -2, -1, which is, let me get my laser pointer out here. -2, -1 right there. So how far is it from the center to -2, -1? Well, we can just draw a little line here and we can count. So that is 1, 2, 3 steps to the left. So we're going to find our horizontal and our vertical distances here. So in this case, we've got 3 units left, which is -3, and then we don't move up or down. So that means that we have 0 up and down movement. But that's going to be our horizontals and our verticals here, -3 and 0. And that's going to be important in just a minute. We're going to multiply those by 3. So that gives me -9 and 0. 3 times 3 is 9, and 0 times 0 is 0. Now what we do with this is we go to our center, and we add this to the x value. So 1 plus -9, and then 1 plus 0. And so in this case, that's going to give me -8, 0. So that's going to be my image point. That's going to be where my image is. That means my image for this is going to be at -8, 0 right here. So that's 3 times the distance from C to P. So that's going to be that far. And if you count, that's 1, 2, 3, and this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's another way you could do this. Let's get rid of all that, and there is P prime right there. So let's take a look at Q. Now I'm not going to do the drawings for each point. I'm just going to kind of show you here. So from Q, from C to Q is 1 unit left, or excuse me, 1 unit right. So that's +1, 2 units up. So +1, +2. So I'm going to multiply those by 3 because that's my scale factor. So that gives me 3, 6. And now I'm going to add these values to my center. So 1 plus 3 is 4. 6 plus 1 is 7. So that's going to be my new point, 4, 7. So that's going to be Q prime. Right there at 4, 7. And then finally, we're going to look at R, which is at 3, -2. Right here, 3, -2. And we're going to go from C to R, which is 2 units right, and 1, 2, 3 units down. So down is negative. So 2 units right is +2. 3 units down is -3. Multiply those by 3 because that's our scale factor. That gives me 6 and -9. And again, I'm going to add these values to our center. So 1 plus 6 is 7. And then -9 plus 1 is -8. So that's going to be my new center, which will be 7, -8. And so there is R prime, is the dilated figure. So now I hope this helps you with the information in the lesson. If you still struggle with dilations as you're doing the first part of the assignment, please let me know in a teacher message or make an appointment for a help session.